All right. I want to welcome all of you to our PolarConnect event with the Arctic Research Consortium of the United States. We're very excited to be hosting this live event with Adeena Teres and maybe her PI, John Woods, will be joining us here soon. This event is focused on NASA's Operation IceBridge project, which we will hear from Adeena what that's all about. Before I get too far along and turn the presentation over to Adeena, we have a few things that we want to share with you. This is a platform called Adobe Connect. Some of you have joined by phone and some of you have joined by voice over IP. In either case, we ask you to mute your phones or the voice over IP until we can ask questions at the end of the presentation. The center of the platform is where the slides will be shown. Adeena has a webcam, and she'll be the only one with a webcam today. We'll see how the band goes and if she can keep it during the presentation or not. And feedback, we'll see who that is. There we go. If you have questions as we go along, please type them in the public chat box. This event is being recorded so that we'll have hopefully a nice audio and movie recording in a few days for you in case you want to reflect back on it. If you haven't already done this, we want everybody to introduce themselves and let us know where you're joining us. So please type in the chat box your location, if you have any students or adults with you, and just give us a sense of where you're coming from. Just so you all know, I am Janet, and I run the PolarTREC program, and I'm based here in Anchorage, Alaska. Judy Fonstock is also online, and she's based in New Hampshire, so we're coming from different places in the world. And, of course, Adeena is in Greenland, and we'll hear more about that in a moment. Adeena is part of the PolarTREC program, Teachers and Researchers Exploring and Collaborating. We're funded by the National Science Foundation, and for Adeena's participation, we have some funding from NASA. It's part of an effort to get teachers working with scientists and so that they can learn more about what kind of science is being done and bring that back into their classroom. Our program is focused on the polar regions, both the Arctic and the Antarctic, and we're really excited to be supporting Adeena and John Woods in this collaboration. As I mentioned earlier, you can type questions in the chat box, and at the end of the presentation, you can also raise your hand. There's a little person that's kind of at the top of your screens. You can use that pull-down menu, and it puts a little hand next to you. And we can all right, muting attendees as I hear feedback. Anyway, we can call on you and you can ask your question live. Of course, feel free to type them in the chat box as we go along, and we will relay the questions to Adeena. So with that, I think we're all ready to pass it on to Adeena, and welcome, and I'm turning it over to you.
Okay, thank you very much. Hello, everybody. I am Adeena Teres, and I am here in Kangerlussuaq, Greenland. First, I was in Thule, Greenland, and I was there for a little over a week. And now I'm here in Kangerlussuaq, and I've been here for a little over a week also. I'm from Marjorie Stoneman Douglas High School in Parkland, Florida. So hello, everybody from Parkland and from all over South Florida and everywhere else. Today it's snowing here, so it's a little bit different than what I'm used to in South Florida. And the weather has been nice, and I'm getting used to living in a very, very cold climate, and I'm loving every minute of it. So a little bit about what I'm doing. I'm part of, let me go back a second. Also, I'm with researcher John Woods. He is from the NASA Operation IceBridge, and he was with me for the first few days in Thule, and he had to go back to Maryland. And I hope he's here today with us. and moving on from there. Okay, so this is Operation IceBridge, and it is a NASA program. And what they do is they have air flights, airplanes. And the airplanes are going to fly over the Arctic regions, and they're going to collect data about the amount of ice and snow in the Arctic regions. And there's 2 satellites that is kind of part of how Operation IceBridge got started. So you have IceSat-1 that went from 2003 to 2009. And there's a new satellite going up either in 2018 or 2019, that's called IceSat-2. But to bridge the gap between the operation of these 2 satellites, IceBridge became the program. So that's how it got its name, Operation IceBridge. It's bridging the gap between satellite number 1 and satellite number 2. And what we do is we fly on an airplane, and our airplane is a turboprop, and it has 4 propellers on it. And it's called a P-3 Orion. And it stays at Wallops Island, Virginia. And it's been specially fitted for the operation that we're doing. So basically the whole inside has been refitted, and it's now a mobile science station. And anytime the Operation IceBridge goes up, they'll put in all of the equipment for Operation IceBridge. When they're not using the plane, they take out the equipment so they can do maintenance on the equipment, maintenance on the plane. They might use the plane for other NASA operations. And the plane is basically our home in the sky for the team about 3 months, and for me about 3 weeks. So I saw a question down here about what happened with the satellite and why it didn't go up for 2016. They're trying to perfect all of the systems on the satellite. So once you send a satellite up into orbit, you can't take it down and fix it again. So if something's not working perfectly, then they don't want to send it up. So right now they're still working to make sure that everything on the satellite works and functions perfectly. And then once they have everything done to the best of their ability, that's when they're going to send it up. So this is a little look inside the P3. And for the P3, you have basically the fuselage. And in the fuselage, on either side, you'll have different data stations. So each station is for a different instrument. The pilots are in the front. We have a large cockpit with no doors. That's different than most commercial airplanes. You get on used to seeing that door, but we don't have that. We have a little kitchen area, so you can see that we have a little microwave, a little refrigerator, a coffee pot, which is essential for all the flight crew. That is our bathroom. The bathroom is at the back of the airplane. So we do have one, and it is luxurious, as you can see. And on the top left-hand picture, you see basically the back of the airplane looking front. So I took that picture standing all the way at the back where the bathroom is and shooting up towards the front. And then right below that, you see the opposite direction. So that's me all the way at the front of the airplane, right in front of the cockpit, taking a picture all the way back. So basically we have this long airplane, free in the middle, and then data stations on the side. Hi Bethel, hi class, I miss you too. So this is a picture of some of the different things that we have on the airplane, some of the different equipment. And at different times, the different equipment will be used. So we're only using some of the equipment right now, not all of it. One of the things we use is the ATM. The ATM is a laser altimeter. So altimeter measures height. And what you're going to do is you shoot down the laser, it bounces back, and the plane can see basically how high the ground is, and it can make a topographic map. A topographic map is a type of map that shows mountains, valleys, it shows topography of the land, how the land is formed, and what different features are on the land. Then it has the McCord's radar sounders, which show how thick the ice sheets are. It has the accumulation and snow radar, which shows how much snow there is on top, and that helps us to see the difference between the snow and the ice, because we want to measure both the amount of snow and the amount of ice. So if you have different radars, you can see, okay, this is the amount of snow, this is the amount of ice. And then we can also see where the ground is. So you can get a full picture of the Arctic. See where the ground level is at, see how much ice is on top of the ground, see how much snow is on top of that. There's a couple other things that the plane is not using right now. The magnometer and the gravimeter are not instruments that we're currently using. And one of the reasons for that is one of the main things that those instruments do is they measure rocks and the age of them, and we know that in Greenland. We know that they're millions of years old, so we're not using that equipment at this time, not for this study.
Hey, Adeena, I just want to interrupt real quick and let you know that John Woods has joined us. So for those of you that are listening to the presentation, John Woods, as Adeena introduced, he's the PI for the NASA Operation IceBridge project. So welcome, John.
Yeah, sorry, I've been on the whole time. I just have a slow mute button, so I apologize.
No worries. So we'll let you feel free to answer any of those questions or jump in and compliment Adeena's presentation as we go along.
Yep, she's doing great.
Hi,
I'll
John.
be here.
Great. All right, thanks, Adeena. Sorry to interrupt.
Going on now. Okay, so a little bit more about our instrument. We have the digital mapping system, and that basically takes pictures, so we can use them. We talked about the Airborne Topographic Mapper, or the ATM, which makes that topographic map. You have an infrared camera. An infrared camera can get the different temperatures of the land, the sea, the ice. We have a snow radar, and again, that measures the amount of snow. We have the McCore's radar, which is used to measure the ice sheet thickness and map the terrain below the ice, which is really important because if you can map the terrain below the ice, you know where the terrain ends and the ice begins. And then terrain, remember, is the word for land. So you know where the land ends, the snow begins, and the ice begins, so you can get a total picture of what's covering the Arctic. And then new this year is the 360 camera, which has become my job to take care of. So during the day, we'll go back and we'll record using this 360 camera, and eventually all of the film will be put together into a nice little movie, and it should be very interesting. And this is the first year they're doing that, so I'm very excited to help out with that and be part of it. So this is a little information about my first flight. We fly different missions for IceBridge. And my first mission was flying flux lines. And you can see at the beginning we get a picture. And that picture is the one on the left-hand side. And it says Northwest Coastal Sea. So at the beginning of each mission, they put up this picture on the fuselage so everybody can kind of take a look at it as we go through our mission during the day. And it tells you exactly where the plane is going to be flying. And for our first one, we flew these flux lines, which you basically take the plane and go up and down the flux lines. And basically that is areas that have already been identified. So those are areas that the plane has flown over before, the satellites have flown over before. Also skiers, if people on skis have actually done studies in the Arctic, and we fly over their lines too. And really what you want to do with these lines is you want to show change over time. So just looking at how much ice in the Arctic now doesn't tell you anything. You need to know how much was before, and you need to know the change over time. What is actually going on in the longer period? So by flying these flux lines, we are generating data that's the same data year after year, so it can be compared to each other. So that the scientists who use the data can get a total picture of what's going on in the Arctic. And if you look at the picture on the top right-hand side of the screen, the one that's in color, that's the same flux lines that you see in the map, but that's actually where the plane is flying. So I stole that from John Sontag's station. I just took a picture of it, and it shows where the plane is on its journey. So the red lines is all the area that we already flew, and the white line all the way in the back is the area that we still have to fly. And John Sagtag basically helps to keep the airplane on course. He's the engineer. Perfect, thank you. He's the engineer, and the pilots they work together to keep the airplane on the right trajectory. In the picture in the lower corner is one of the beautiful mountains that I saw that day. So I just really enjoyed seeing that one. It was my first flight. It was my first big picture, and since then I've gotten a bunch of really good pictures. So this is one of the glaciers we flew over. Are we having problems hearing?
Yeah, it sounds like some people might be having audio issues. If somebody else is having an audio issue, please type it in the chat box. Okay, keep going, Adeena. Thank you.
Okay. So this is a picture of Petermann Glacier, which is one of the glaciers we flew over in northern Greenland. And these are my flights out of Thule. And one of the cool things about this glacier is that it was in the news shortly after we flew over it. So it was in a Washington Post article, and the plane was told to fly over it because one of the scientists on a satellite picture showed that there was a new crack in the ice, and they wanted better data from our plane. So our plane flew over it again to take a good picture of this new crack that formed. And from this new data, the scientists can get a better idea of what's happening on this glacier. So using the airplanes are important. Even though you have the satellites pass over an area basically about every 90 days. And you have to wait until you need that new data again for the satellite to pass over it. But for us on the airplane, if somebody needs something, then they say, hey, and make a request, can you fly over this? Then if the plane is not doing anything else important at the time, or if they can fit it into their schedule, then they'll fly over that certain area. And for the plane, they have different priority missions, and in Thule, when we were there, we finished all our high priority missions. And the high priority missions are basically missions that scientists have requested that the plane do so they can get the most information and the information that they need for their studies. And the coolest thing about, or one of the things that I find the coolest about Operation IceBridge is that they do crowdsourcing for their data. So basically, anybody who wants to use their data can use it. It can be a scientist in another country. It can be a scientist in America. It can be a high school student, elementary student. You can go online, you can look at their data, and you can use it, and it's free and open to the public for anybody. And if you see on there, you can see some of the different images. On the top left-hand corner, it is a radar image. And then you can see on the image below that is one of the cracks. If you look on the right of your screen, you can see the infrared image. So you can see that the crack is slightly different in color than the rest of the area around it. And then you can see a better view of the crack at the bottom of the picture. So I wanted to talk about a little bit about not just flying, but other things that I've been doing and seeing in Greenland. So when we were in Thule Air Force Base, we saw a lot of Arctic foxes and a lot of Arctic hares. And I was kind of shocked actually to see that the Arctic foxes were not all white in color. I thought they'd all be like white or really light gray, but that's an Arctic fox up there, and you can tell that he's a dark color. The Arctic foxes at Thule Air Force Base are a little spoiled. They're kind of like our raccoons in America and in Florida. So they live on the base and they eat the scraps. The little bunnies, they're Arctic hares, and they're all over Thule, Greenland. We saw a bunch of those. And again, the ones in the base are beggar bunnies, as we used to call them. They would wait outside and people would feed them. But if you go out away from the base, then you see them all out there on the hills, and they're eating these little tiny plants that just come up, and they're all over the place. And it's kind of fascinating to see that there's, no trees, there's no shrubs. It's all very tiny plants, and you have all this life out there. So you have foxes, you have musk ox, which I don't have pictures of. We saw some, but they were too far away for me to take a picture of. And then you have the Arctic hares. And when I was there, it was Armed Forces Day. So the weekend I was there, they had dog sled races. So those are some of the dogs after the race. They ran hard, so right now they're relaxing after the race. And these dogs are not like your dogs at home. They're not pets. They're actually work dogs. So they're friendly to an extent, but they really have a job to do. And their job is to transport people from area to area. And you know, they are all together on the team, and we watched them get fed, and we watched them run, and it was very exciting. I've never seen actual sled dogs before running on ice, and it was very exciting to get the chance and opportunity to see it. Here are some of the views from the airplane, some of the things I've been seeing. So Greenland is very mountainous. When I first got there, I didn't realize how mountainous Greenland actually was. And depending on where you are, it's either covered in ice, and you also have some areas that are brown. So basically, when I first flew into Greenland, I flew into Kangerlussuaq, where I'm at now. And then we went up north to Thule, Greenland. And in Kangerlussuaq, when I first flew in there on the way, as we flew up the coast, it was all white. You could see the mountains, and then you could see the ice shelf. And as we got closer and closer to Thule, Greenland, it got a little bit more brown. And now that I'm back in Kangerlussuaq, it's even more brown because it's warmer here now. When I was in Thule, it never got above freezing. So I was lucky in Kangerlussuaq. We had one day where it was 32 degrees, so just at freezing. So that was very exciting to have that nice warm temperature. And it's funny going to like being here now from being in Thule, Kangerlussuaq to me actually feels warm. So even though it's 32 degrees outside and it's still considered freezing, I'm like, oh, this is a nice warm day because, you know, it's not 10 degrees or -1 at night. And another big difference between Thule and where I am now is at Thule, we're much farther up in the Arctic Circle. So in Kangerlussuaq, we're still above the Arctic Circle, but we're just above it. So in Thule, when I go to bed at night, it'd be still light out. The sun basically never set. And here in Kangerlussuaq, it does get dark at night. So that's actually kind of nice. I'm sleeping much better than I was sleeping when we were in Thule. Yes, and for 32 degrees Fahrenheit, that's 0 degrees Celsius. So basically, it's been freezing the whole entire time I've been here. So a little bit about my experiences so far. Not only have I gotten a chance to be in the airplane, I've also gotten a chance to do some hiking. So my very first day I was there, John Wood took me out to the ice sheet, and we hiked up a huge mountain. We got to the ice sheet, and when you get out there, it's super quiet. There is nothing out there. It's just silence for miles. And then as you walk, you can kind of hear the crunch of the snow underneath your feet, and it's amazing. And I was very lucky, and thank you, John, for taking me out there. And then also in the pictures, you can see in the middle picture, there is a plane buried with underneath the snow. It crashed several years ago, and the IceBridge plane has been flying over it ever since. And over time, you can see the plane getting more and more buried by the snow. So when it first crashed, you could see almost the whole entire plane. And as time goes by, it keeps on getting more snow covered. And I see some of the questions here, and I'm not exactly sure if the plane registers on all the data. I know that that picture, it does register on the DMS data. So you can see it on the pictures, but I don't know how it is affected by the radar data.
Yeah, and Adeena, we'll get to the questions too at the end, so you don't have to read the chat.
Okay, sorry about that then. In the top right-hand corner, I thought it was funny. They have a gym in Thule, and they have this beautiful picture of palm trees at the beach. So to me, that's home because I'm in Florida and we have lots of palm trees. So looking at that, I just had to take a picture of it. There's a little massage chair there and one of the areas you can go to just kind of relax. And I was like, okay, so they like to relax the same place I like to relax, at the beach. And down at the bottom left-hand corner is one of the dog sleds. And it's a very up-close view because I don't know if you can see it, but on the bottom there's a sticker, and it's the Operation IceBridge sticker. So we gave that sticker to one of the guys, and he slapped it on his sled. And in my mind, that sled won. In reality, it did not. But I still think it was the best decorated sled out of all the sleds that were in the race. And you can see for the sled, it's made out of wood. They make them themselves. They construct it themselves. They use tarps on the bottom to kind of keep out the snow. And then on top of that, they have steel pelts to keep them warm as they go and drive these dogs. They went for several miles, and it's crazy how fast these dogs actually go and how far they travel. And then on the right-hand side, what is a day without a good lunch? So I don't know, I thought it was kind of funny. On Sundays, they have traditional Danish food. So traditional Danish food is a lot of salmon and a lot of pickled herring and different vegetables. And one thing about the food in Thule is that it was very abundant and delicious. So probably gained about 5 pounds while being on this lovely vacation, no, not really, work and Operation IceBridge. So a little bit about what I've learned so far. If you're looking at the picture at the top, those are all the different flags that are the places represented at Thule Air Force Base in Greenland. So you have American contingency, Canadian, you have Danish, and then you have the Greenlandic flag. So all of those people are represented at Thule. And you have just a lovely picture, kind of, you can see kind of the glacier at the bottom of it, and mountains on the sides, of the ice on the sides. That's me day one outside of the airplane. And one of the main things that I've learned while I'm on this Operation IceBridge is not to use the words global warming. That is what we're not saying anymore. It's actually climate change. And one of the scientists here, her name is Kelly, and she is, I call her Dr. Glacier because she's a glaciologist. And she has been helping me understand this. So climate change is basically what is going on, because you're looking at different climates, and some areas are getting warmer, some areas are getting colder, but basically climate is changing, and that's what these scientists are getting data about. And the idea is, how is it changing and why is it changing? And climate through the years has always changed, but what we really want to know is, what is the human effect? Is the humans making the changes occur faster, or are these changes just in a natural cycle? And that's one of the things that this operation does, and one of the reasons why I think it's so important that we support Operation IceBridge and polar studies.
Okay. So there were some questions that came up, and I don't know if they got answered while you were presenting there. But let's see. One of them was, how are humans benefiting from this research? Elizabeth R., 11th grade student.
Well, any person in the world who wants to can actually use this research. So like I said, it's crowdsourced data. So that means that different scientists all over the world can use this data. And like I said, it's showing different climate change. And one of the good things about it is it shows change over time. So if you just look at something, you can't see what is going on. So just looking at temperature and weather is temporary and for one location. But if you want to see climate you have to look at on a global scale, and it has to be over time. So one of the reasons why this information is so important is because it gives scientists an idea of what has happened in the past and what is happening now. And Operation IceBridge flies a lot of the same patterns year after year after year. So if you go through the data, you can see change over time. And change over time really shows scientists what is occurring.
Okay, great, thanks. I know that John might have addressed some of these, but maybe you or him can speak to how you can become involved with Operation IceBridge as a teacher/scientist.
Sure. There's a lot of different things you can do with Operation IceBridge. You can chat with the airplane. So one of the things you can do is you can sign up to chat and then ask any questions you want, and the crew of the airplane will actually answer the questions as they're flying. And you can do that through, if you go onto the Operation IceBridge webpage, you can go there and there's a link onto how to join the X-Chat and talk with them. You can also download all the information. You can also download all the information from the Operation IceBridge webpage, and you can use, they post their data and you can use it in their classroom. One of the things that I want to do in my classroom when I get back is to look at the DMS data, which is the pictures that Operation IceBridge takes, and I want to kind of see if I can overlay them over time so the students can see the amount of change in the ice over time. Another thing you can do is you can take the data and you can use the radar data, you can use the topographic map data. So a lot of the data is usable for as far as you want to stretch the your ideas of what you want to study. John, do you have anything you want to add to that?
Okay. Yeah, John, anything you want to?
Yeah, I just shared that we should definitely add them to our educator distribution list that Emily Schaller at the NASA Airborne Science Communication Shop runs. So if they share, or Judy, if you have a list of teachers that are participating today, we can get them added to that distribution list.
Oh, certainly. Yeah, we can definitely share that with you guys. That would be great. Another question that came up from an 11th grade student was, what time is it for you in Greenland and how long does it stay light?
For me, it is 3:33 in the afternoon. And when I was in Thule, it stayed light basically 24 hours. But now that I'm in Kanger, it stays light until about like 9:30, 10 o'clock at night. And then the sun starts to go down, and then the sun comes back up around, I would say, like 4 o'clock in the morning. So we definitely have some nice dark time here, which is much better for sleeping. When I was in Thule, it was very hard for me to sleep because you would wake up in the middle of the night and the sun would still be out, and it would be like, okay, what time is it? And I'd always have to check my clock. Okay, no, not time to wake up. Time to go back to sleep. It would be like 1 o'clock in the morning, and it would look the same as it did at 6 o'clock at night.
Yep, it's starting to be like that here in Alaska. Long daylight hours. Okay, let's see. Another question, and I believe John might have answered this in the chat, but we'll just put it out there. Kelly's class was wondering, does the plane register, that plane that was buried, does it register on the data? I don't remember what the answer was.
I'll have to rely on John for that. I know it shows up in the DMS data because I know we took pictures of it, but I don't know how it would be affected by the radar data.
Yeah, they can actually see it. It shows up as a signature in both the radar data and even on the ATM data. So it's a large enough object that they can actually spot that from in all the data sets.
Okay. let's see. The next question was, how long will you stay in Greenland, and how long do you stay in the airplane? Mrs. Edwards, 4th grade.
Well, I'll be in Greenland for a little over 3 weeks total time. And our days in the airplane are about 8 hours a day. So we're in the airplane for 8 hours a day. In Thule, we took off really early in the morning. We would take off around 8 o'clock and not get home until 4. And then now that we're in Kanger, we have a little bit of a later day, so we get to wake up at 9, or not wake up, sorry, take off at 9 and land around 5 o'clock. So it's about 8 hours in the airplane. And some of the time, you know, you're looking at the equipment, you're looking out the window. I only got sick once on the plane, but it's been very bumpy. So on the time that it's bumpy, we have to be locked in our seats. And on the other time, we can get up and walk around the plane. It's not like your normal airplane. So when you get on a normal airplane, you know, you have a flight attendant and they welcome you on. This is different. We all go on to our own seats and our own stations. Everybody gets their operation, their equipment ready for what they need to do for the day. We put on our seatbelts, and our seatbelts look different than a regular seatbelt on an airplane. So our seatbelts have a strap that goes around the waist and a harness that goes over the shoulders. And then at every station, they have a headset, and you can listen to the pilots and the other people within the cabin talking to each other, telling you what's going on as you fly. And there's no flight attendants on this flight. So as soon as we're up in the air and it's clear, the pilots come over the headset, and they'll tell you if you can get up. And then same thing, if it gets bumpy, they just tell you to sit down. But basically, you know, once you're in the airplane and you're up, you can get up, walk around, and do whatever you need to do for the getting information.
Okay, great. Let's see, where was I on my list? Oh, one of the students would like to know why there was a crack in the ice, and sorry, it's moving on me, the screen is, and what is making that happen?
Well, different things make different cracks.
Maybe
yeah.
John?
John, you want to take it?
Oh, go ahead.
Oh, I was just going to say different things make different cracks in the ice, and it depends if it's land ice and sea ice. They crack differently from what I've learned. So basically, you know, if you have land ice, what's happening there is that there's still ice flow. So it piles up in the middle of the ice sheet in Greenland, and it's trying to flow to the sides. So it'll flow at different rates. So as the ice flows at different rates, you'll get cracks in certain areas. And then for water closer to, or ice closer to the edge of the, on the coastline, as it gets closer and closer to the water's edge, you'll have these glaciers forming. And at the edge of glaciers, you usually sometimes have cracks, where you have the glacier meeting the water, and again, that glacier is moving, and that can create cracks as it moves at different speeds. Anything you want to add to that, John?
Yeah, and the crack you showed, I think, was from Petermann, right? Is that the one that was?
Correct.
Yeah, so remember we had that talk up there. There's a guy studying right now from the University of Delaware that spent last summer on Petermann. And, you know, Petermann is one of the more active glaciers in Greenland right now. And that's where a lot of the science is being done to understand why their cracks are being formed or they're receding so rapidly. And for all the reasons that Adeena already mentioned, and also the interaction of the water against the bed, so where these drainage channels are occurring, you know, how that's impacting the flow of these glaciers. That's sort of the cutting-edge science that's going on right now.
All right. Thanks. Let's see. I think this is a good question. Why is Operation IceBridge so important to you, Jonathan, 4th grade?
Well, it's important to me because it's giving me a chance to learn new things. Before I came here, I didn't nearly know as much as I did about the Arctic and the polar regions and why they are so important to the world around us. And as I go through this program, I'm learning more and more every day. And they are essential for our climate, for climate stability. So I'm learning that. So, and you can definitely tell that as the poles change, they're going to be the first things that are really going to show climate change. So if you want to learn more about climate change, the best areas to study are the poles.
John, you want to add anything to that as a scientist?
Yeah, I think it's just really important, again, that NASA is continuously monitoring both poles. And, to bridge that gap between the two satellite missions is really important because, imagine having little or no data for a 10-year gap or an 8-year gap and not understanding those changes that took place during that time, especially all the rapid changes that we're seeing now. So that's why IceBridge is just really important. So it's not like we had 0 observations over a long period of time that would have given us a much lesser understanding of what's happening.
Also, the plane can fly.
Okay, and while I have you, I'm going to actually, oh, go ahead. Sorry, Adeena, what do you want to say?
I was going to say the plane can fly places that the satellites can't go back to, so you can get more information or information at different times. So even when you have the satellites there, the planes are also really important to keep flying.
Good point. Well, I have you both kind of focused on that. I'm going to go to the last question that came up, which is, where does funding come from for missions like this, and what kind of a background does a scientist need in order to do this kind of research? From Nico.
John, would you like to take that one?
Yeah, sure. So we're actually funded, all NASA funding is all publicly funded, so we're actually funded through, Congress and budgets coming out of Washington, D.C. And our particular program office is the cryosphere program. So the cryosphere covers both poles as well as the high altitude of the Himalayas. So that program manager at NASA is the one who is actually funding Operation IceBridge to bridge the gap between the two satellite missions. And IceBridge is made up of all sorts of scientists and engineers. That's the other big piece of this, is that we have a huge engineering team. All the instrument teams are basically filled with engineers. The scientists are glaciologists. We have oceanographers. We have sea ice specialists. We have meteorologists, folks that are interested in the weather, involved in the teams. And then finally, the glorious piece of the air crew. So the air crew is made up of pilots, mechanics, flight engineers. So it's a really varied team, which makes IceBridge really so interesting.
And I was told
All right, thank you.
Sorry.
Go ahead.
I get excited. I remember things after John speaks. But I was told, he helped jog my memory. I was told that a lot of the engineers designed the radar systems themselves. So they really know their own systems. And when we're on the plane, if something breaks or is not working correctly, basically everybody will jump up and they'll start helping out. And if you see in the top picture there, even after we get off the plane, that's actually in the hangar in Thule, and they just start looking at the data as soon as they get off the plane. So the most important information for them is how much data they keep. And at the end of the day, they'll always go through and they ask every station, when did you start recording? When did you stop recording? How much data did you get? And they're looking for like 99, 98, 97% amount of data for each station collected, and we've been getting that, and that's amazing. So these guys know what they're doing, and if something's not going right, again, they jump up. It doesn't matter whose station is. They all help out, and they can take care of a problem in a few seconds, and if it takes longer than that, then as soon as they need a part or the plane lands, because some of these systems you can't reach from inside the plane, they'll fix it immediately. And also some of the things, if something goes wrong, you can fix it from inside the plane. So there's a couple times where I've seen them open up the floorboards and work on something. And usually it's amazing to see these guys and how intense they are. And they've been doing this for years and years. And they still get excited. Their eyes light up like little children. Like when I ask a question, they're like, oh, let me tell you the answer. So they're very excited. They know their systems. They're amazing.
That kind of relates to two questions where people are mostly asking how many people are in the plane at one time. So I'll let you respond to that.
There's about 24 seats on the plane, so it can hold a lot of people. The crew, I think there's about 6 to 8 guys actually flying on the crew. And then there's the different scientists, and we have scientists come in and out. So one of the things that I thought was very cool is a lot of people, they don't necessarily stay here the whole time, so we'll have visiting scientists. They also have visitors. So one of the things about Operation IceBridge and NASA that is amazing is that when we were at Thule, they invited people from the base onto the plane and had guests on board. And they do the same thing. So now that we're in Kanger, they have staff from the airport here come on the plane. So there'll be a lot of different people coming on. Right now we have Kelly on, and she's a glaciologist. There are 3 different radar systems, and there's scientists for each of those. There's a scientist for the DMS data. John Santag, he's a scientist and engineer. I'm missing some people. But there's definitely a lot of us. Jefferson was there, and he did.
Okay. Yeah, so everybody has a role in the airplane. They're just hanging out.
Exactly.
Let's see. I have a question back up here from Liberty Pines. They want, oh wait, sorry, we already asked that. Oh no. Do you fly science missions over Petermann each year, or was this year a directed mission because of the new crack observed?
Yes to both. So every year they fly over Petermann Glacier. They have different priority missions. So they have high priority missions, and there was a scientist who requested that they fly over Petermann Glacier this year, and so the airplane did. But like I said before, one of the good things about this, and one of the things they want to do, is they want to keep on flying over the same places so they can see what happens year to year. Because, again, you don't want to look at just one snapshot in time. You look at one snapshot in time, and you get like a little bit of picture, not the whole story. So if you go to the same place over a long period of time, year after year after year, you get the story, not just the picture. So it's like if you're watching a movie and you get the trailer. The trailer is just like one little piece of the movie. Will you like it? Hopefully. It kind of gets you interested. But then the whole movie gives you that whole story, and that's what this is. 1 year is just the trailer. Okay, so what is this? This is interesting. It's a new crack, but what's going on with this crack? How does it form? We have to look over the whole story year after year after year to see basically what's going on.
Okay, cool. Let's see. We have another question about climate change, and how does climate change affect the animals in Greenland? And if you don't know, that's okay.
I actually had one of this question on my journal. And as of right now, from the people I've talked to at Thule Air Force Base, it's not affecting the Arctic fox and the hares that live there now. One of the main things, or the questions, is about the polar bears, and that's still being observed. So basically, polar bears need sea ice for survival. So measuring the amount of sea ice and seeing sea.
Oops, we lost you there for a moment, Adeena, so I don't know if you can still hear me. Oh, you're cutting in and out. All right. Maybe turn off your webcam real quick, Adeena, if you can hear me. Otherwise, we might have just lost her. All right. Yep, I think she disappeared here for a moment. We'll let Adeena try to figure out her technical issues, and in the meantime, related to animals and the effects of climate change, as she was talking about, there's actually several PolarTREC teachers that have been working with scientists that are working with animals in the Arctic as well as Antarctica, and you can read about what they're finding through the PolarTREC website. A couple of years ago, there was a teacher that worked with some polar bear biologists and up in the northern part of Alaska, and they have a lot of information about climate change and polar bears. Oh, there you go. And we currently have a teacher that's up at Toolik Field Station looking at ground squirrels. So there's some journals related to animals. All right. I see you're back, Adeena. Sorry, we lost you there for a moment.
Yeah, my internet seems to not always want to behave itself, so, I had to be a little finicky, had to show off a little bit.
Oh, I'm impressed. It did pretty good all along. So we're lucky to be able to see you and hear you so well from Greenland. It's always amazing. While you were getting our technology, I kind of directed some people to climate change things and journals related to that and the animals. So I don't know if you want to finish or move on to another question.
I don't know how much you heard. I was talking a little bit about polar bears and saying that that's the last thing I heard. I didn't really know that much about it. So, and then I kind of lost you all.
That's all right. Yeah, we had actually a PolarTREC teacher that worked with a polar bear biologist a number of years ago, and they focused right on that issue. So when we get a moment, we'll be sure to share that link to that journal, those journals as well, because it's pretty interesting science. Let's move on, since we only got about 10 more minutes here before we have to sign off. But we have a question from Marla's group. How long will you be doing this, and when will you return to Douglas? And they hope that they can come here, that you can come and speak with them.
I would love to come and speak with them. I'm actually supposed to return May 3rd, so I should be back at Douglas May 4th or 5th. And I can't wait to get back there. And once I get back to Florida, I would love to visit different schools, show you my pictures, talk about all about my experiences.
Okay. There was a question from SD High. Do you see northern lights at night there?
I have not seen them yet. A couple of days ago, I was told that they came out between like 1 or 2 o'clock in the morning. So we work basically in Kangerlussuaq 6 days a week. So we start on Monday, we work all the way through Saturday, so our only day off is Saturday night. So Saturday night, I stayed up as late as I could, and I did not see the northern lights. So hopefully this Saturday I'm going to do it again and have another chance to hopefully see them. But I have not seen them yet. And then when we were in Thule, it was light all the time. So I really didn't get a chance to see them at all.
Yeah, it gets harder and harder as we get more and more daylight. But the northern lights are there all the time. It's just a matter of whether we see them or not. So there was a question, hold on, about from... What advice would you give to a high school student who is interested in doing polar research? What should we get involved in now? Isabel.
I would say go out there and find any organization that you can that supports polar research. You can go to the NASA Operation IceBridge website and look at their information. There's ARCIS and NSF, Polar Research Consortium. There's a lot of places out there where you can start learning about polar research. And then start looking at schools. Look at ones that have a good program for looking at polar activities. Think about what you want to study, because polar research, there's many different aspects that you can study. For us, we're studying the ice sheets, but I know a lot of the other people who are in PolarTREC are studying the biology involved in Arctic studies. You could study ocean currents. So find the thing that you find the most interesting, get information about it, and see where that will take you.
Excellent. And I'm putting some of those links up here for people, but there are, both for educators and other researchers as well as students, there are some free organizations that you can belong to. Polar Educators International is a group of people that are interested in education-related issues around the polar regions. The Association of Early Career Polar Researchers is a great place for both students interested in getting into polar sciences as well as teachers trying to connect with scientists. They're all over the world. Of course, the organization that is hosting PolarTREC, ARCUS. We also do individual memberships as well as institutional memberships, and are connected with the Arctic communities as well. So lots of good places. And I don't know, John, if you have any other things that you'd like to share related to that topic?
No, I think you guys had that covered pretty well, but like Adeena was saying, definitely a strong background in the STEM disciplines is where you want to start. And then even we had a couple of English majors from the Naval Academy join us earlier in the campaign because we believe, communicating the science piece is another key piece. So having a good literary background really helps as well.
Okay, it looks like we have another question from Rivero. My students want to know, how long were your hikes?
They were several miles. So we did a couple hikes there, like 2 miles, one that was like 5 miles. And I learned that I am not in shape for Arctic working out. I run when I'm in Florida and everything is flat there and warm. But as soon as you start walking and you're in the cold, and like today we were in snow basically up to our knees, it is much different. And I was so tired by the end. We were climbing up these mountains, and there's high elevation. When I live in Florida, we're basically at sea level. But the higher you go in the mountains, the more your lungs have to work. So it was definitely tough doing some of these hikes, but when you get up to the top of these areas and you're seeing these places that few people have ever been to, and all you look around, you see like just white snow, and there's no sound for miles, it's amazing. It is like a winter wonderland. I wish I could like bring you all with me one day, and we'll just like trek out onto the ice caps, and you can see for yourself. We were at a glacier on Sunday, and you can actually like hear the water dripping. And we were lucky enough, or unlucky enough, depending on how you feel, about ice calving. We saw a part of the glacier actually fall off, and we were very safe. So we had a glaciologist with us, and she was telling us exactly where to go. But as you're walking along the edge of this glacier, they had flags, and the flags would show you like the edge of the glacier, which was unstable, versus like the rest of the glacier that you could walk on. So it was amazing to do some of these hikes.
Yeah, it sounds wonderful. Make sure you take lots of recordings of all those sounds while you're out there. I have them. So you can remember it later on. There was one question I did miss that was way back when, and this will probably be for both you and John. Does fog and cloudiness affect the accuracy of the data?
Definitely. So one of the things that I do, and I'm actually falling in love with it, is going to weather every morning. So I have to wake up a little extra early for that, but every morning, John Sontag and one of the pilots, Scott Farley, they always go over to the weather station at the airport, and they look at all different weather maps and everything that's affecting it. So they look at wind. They look at the amount of clouds. They look at precipitation. Because if there's too many clouds in the atmosphere, then the instruments won't work, and they won't get reliable data. So they have all these different missions. They have high priority missions, baseline missions, lower priority missions, and based on the weather of the day, they'll decide what mission to do and what area to do it in. So they have a set number of missions and certain missions that they have to do, but no exact order to the missions. So if there's an area and it looks cloudy that day, they won't do that mission, they'll do another mission. So usually they have a mission that they really want to do and a couple backup missions depending on weather. And we only had one weather day while I was on the trip so far, but this week we're supposed to be getting some bad weather here in Kanger, so we're crossing our fingers that we'll be able to fly. And it's not just weather in Kanger, it's the weather in the area that we're going to. So Kanger weather today was like snowy, but where they're actually flying today, even though I'm not with them, that's uncloudy, so they can go there. So they look at weather all over the place and try to find the clearest area so they can get the best and the most data that they can.
Excellent. Well, we are going to wrap this up here. Before people start disappearing, we want people to let us know what you think about joining this PolarConnect event. And I just want to say thank you, John and Adeena, for your presentation today. It was really good, and you're getting lots of kudos there. I'm going to stop the recording, but at the same time, you guys that are out there in virtual land, you can say thanks and open up your mics and say hello to Adeena and John.